So let's start this lesson with taking a look at a couple of geometries that we would be using throughout this tutorial. And we have a ship geo and a cliff geo. So the cliff geo is essentially this geometry, this planar geometry that we would be using to define the bounds of our flip tank, i.e. how big or small our flip tank would be, what would be the dimensions of our flip tank would be in X, Y, and Z. So we would be using this. So obviously I scaled it down a bit, and at the minute it's sitting at 185 meters by 56 meters in Y and 61 meters in Z. So it's pretty big if you really think about it. And then the other geometry that I have here is the cliff collider. Now the cliff collider is again the same geometry, but I have extruded it down and on the back, so we can use this efficiently as our collider with our flip tank. So that's important. So the only difference between this and that is the depth information that we have in the collider, because obviously the colliders, when you use colliders with flip fluids, the colliders need to be not planar. They need to have some sort of depth to it. So they're a 3D object instead of, well, plane object. And yeah, that's pretty much from the cliff. We're gonna take a look. We're gonna come back to the cliff geometries later as well, because we would be VDBing these and we would be using a bound sub to define the bounds of our flip tank. And the other geometry that I want to talk about is our spaceship here. So this is how I'm importing it from the disk as it is. And then I'm using a facet node. So if I show you this, you see the normals are a bit weird. So I'm using a facet node and checking on the post-compute normals. So our normals are fine. So you can see that normals, weird normals, completely okay normals. And then I'm using a transform node where I'm transforming the ship by 0.025 in the uniform scale. So it's small, and I'm obviously positioning it in the Z as well here. So if I middle click on my facet, you can see it's massive, 1,000 meters. That's crazy. So scaling it down brings it down to 23 meters, 24 meters by 8 meters by 25 meters, which is believable. And then I'm using a transform node to sort of do this animation, which is just literally going from up and down and in like forward into the tank. And then there is another transform where I'm using the cos and sine functions in the rotation of X and Z respectively. Now what I'm doing here is, so if I disable this and if I visualize this, you can see there is nothing that's going on here, but with this cos and sine functions in the rotational strings, you can see that ship is kind of swiveling a bit. So when it goes down, it doesn't go down in a linear fashion. It has some sort of rotation to it. So you can see the ship is not as stable going down. So essentially what I'm doing is I'm saying cos $f, so every frame into 15 into 4. So let's say if I take down into 4 from both of these, you can see it's going to do it very slowly. If I essentially put this 15 to, let's say, 100, you can see it actually controls the frequency of my noise, of my cos wave and sine waves. So I found that 15 to be a decent value. And then what I want is I want to take this cos $f into 15, and then I'm just going to multiply it outside the brackets to speed that up. So it's not going to change the frequency, but it's going to change the time scale into 4. Nope, into 4. And it's the same thing with sine as well. So the reason that I used cos here and sine there is to have some variation, because sine and cos waves are slightly different from each other when they go up and down. So yes, and when I enable this, you can see the ship's going to animate, and it's going to have some like this rotation to it. Okay, and then I'm also doing another transform node to sort of manually translating and rotating the ship to match my scene a bit better. And I'll be able to show you guys this in a much better way when we actually have our flip tank ready and set up. And then doing the time blend to calculate the subframes. So I'm making sure in the time blend I'm doing it by frame, and then what it would do is it would calculate the subframe data. So when we retime it by 0.8, it doesn't jitter. So I'm essentially just retiming it a little slower. Okay, and then color, just a color swap to like make it a bit gray, and then I'm saving this out. And then obviously, again, we would be coming back to this when we want to create the VDB of our ship geometry, so as to use that VDB to collide it with our flip tank. Okay, so yes, we have our ship geometry and we have our cliff geometry here, and we will be coming back to these two to create the VDBs in a later chapter. For now, let's take a look on how we can set up our flip tank.